So what I will be talking about today is internal developer platforms, right? So this is another IDP. We had in the previous talk, we had an IDP, but this is another type of IDP. I'll explain what IDP, internal developer platform, is later. So basically what we want to look at is to see how to integrate AI into these internal developer platforms and how that would support or facilitate productivity improvements. My name is Malith Jayasinghe. I'm the VP of Research and AI at WSO2. I'm not going to introduce myself. I'll get to the presentation. Right. So let's first try to understand what an internal developer platform is and the problem that it tries to solve, right? So an internal developer platform is the backbone of an organization's software development and delivery. So it's got the tools and services for development teams to create, deploy, and manage cloud native applications, right? So there are multiple reasons why one wants to adapt, such a platform. One reason is we want developers to focus on coding and innovate, basically trying to solve the core problems without having to, worry about the complexities of the underlying infrastructure, such as Kubernetes and so on. And also these internal developer platforms will have, better user experience. I'll get to that later and how AI does it. And also another important point is these platforms will allow you to take your code to production securely and faster, right? So typically these platforms are, built by teams and managed by teams. There's a term this is coming of called platform engineering teams. They are the ones who build, in particular in large organizations. But what is becoming now, very popular and which is a growing area is that, internal developer platforms are being made available as a service, right? So what that means is organizations don't have to, build these platforms from scratch. Rather, they can buy or they can, use it as a service. So WSO2, we also have a internal developer platform, which is called Choreo. But this presentation is not about Choreo. So this is a concept level presentation, but if you are interested, you can take a look at, Choreo. Right, let's move on. Right, so let's take a look at the software development process. We call this software manufacturing or whatever the term might be. So you may be already familiar with this. So this is about the stages that you would go through when you want to code to production. So there are multiple stages in this. So you start with designing your software. So this is the design phase, identifying the high level components. And then of course, then you'll go and develop, right? So this is the code writing part. Then you will deploy it into production, right? So before deploying into production, you may deploy it into, other environments and do testing and so on, like for example, development environment, staging environment, and so on. And then once it's deployed, you'll have to manage it, right? And also the reuse is one of the key concepts in software engineering, which the internal developer platform also supports. And then once it's in production, you have to observe your applications, monitor them, detect anomalies, and if there's any issues, you'll have to fix them. Another important aspect of this is the governance part, right? So organizations typically have the governance policies, which you'll have to adapt. So you'll have to support those ones also. So what an internal developer platform does is that it consolidates tools and capabilities into a single solution to solve the software engineering and delivery problem. So there are two sides to this. One side is the enterprise software engineering development, right? What are the best practices there? And you may have heard of things such as API API first development, domain-driven design, microservice architecture. So there are various best practices that are being used when you design and develop software. So that is one side of it. And the platforms can enforce some of these or all of them through various different tools. Then the other side is the delivery or the infrastructure level capabilities, such as resource optimization, observability, the operational business insights, and so on. So these are available as features, or these are the abstractions that are provided to developers so that they don't have to build it themselves. When you go to these platforms, they are already there. Right. So what is the role of AI in the context of internal developer platform? So there are two angles. First one is AI for the internal developer platform. So that is basically making developers more productive. Developers who are using these platforms, how can you make them productive? That's the first angle. So that is by building various kinds of copilots or doing automations and so on. Then there's the other angle of this, that is about using the internal developer platforms to build AI applications and integrating those AI applications to your enterprise application. Because these days your enterprise applications consist of AI components or the AI APIs and the non-AI APIs, which are the other services that are running. So you need to be able to integrate these things together to create the experience that you want to create, right? So there are various challenges there, which you'll have to deal with. Now, this is where these new concepts such as AI gateway is coming up. So what I'll be focusing today is the first one, right? The developer productivity. So second one will, I guess we can discuss it in a separate session, right? Let's now move on. So I have put this one also. So there's a term coming up called AI augmented software engineering. Now this has a relationship to internal developer platforms. So we'll see what that is. Now, AI augmented software engineering is I've seen this in particular. This is being used by various analysts. So this also talks about adoption of AI in the SLDC, software development lifecycle, right? So this is a growing market. And so 2023, this was 2.1 billion US dollars, and this is expected to grow to a value of 26.8 billion. Right. So this is the AI augmented engineering market. It's not the internal developer platform market, right? So the relationship between AI augmented software engineering and AI for internal developer platforms is that AI augmented software engineering talks about at a broad level, what can you do to make the software engineering more efficient? Now, IDP, Internal Developer Platform, actually provide an environment where the AI augmented engineering practices can be applied and implemented. So that's the relationship between the two. So how is this experience delivered to the developers who are using these platforms? So there's two ways. One is these platforms usually have product consoles. You go and log into these consoles. So these are typically web-based consoles where the developers will log in, and then they create components and they link GitHub repositories, and then they deploy them and then run them in production and observe them, right? So these AI capabilities, these assistants can be introduced into these product consoles to make this development process more efficient. And also there are, various types of plugins that these developer platforms provide, such as VS Code plugins, which can be, installed into your development environment. So this, then they can be integrated into those development environments also, and that these development environments aware of the various components, various artifacts, the data sources that you have in the internal developer platform, right? So through that also you can improve the productivity of developers who are using these platforms, right? So what are the primary use cases? Let's take a look at some of these. Now, these use cases can be categorized in different ways, right? Depending on the area or, by going through the life cycle and so on, right? So this categorization is basically, by looking at the software development life and delivery life cycle, and then let's take a look at what kind of use cases are there and how we can use AI to, improve the efficiency. Now, the first one I spoke about the design, right? So software design is the first thing that you would do when you are designing software. So then the question becomes how you can use AI in that for software design. So this may involve, for example, generating architecture diagrams and so on, following certain best practices, such as domain-driven design or microservices architecture best practices. There's, well-known architecture patterns called cell-based architecture and so on. So the platform can be made aware of these best practices, and the tools that the platform provide, this knowledge can be embedded into those tools so that when these architecture diagrams are, generated or created, you can follow those best practices. Right. So that is about doing the, overall architecture, right? Then once that is done, you'll have to go and design your APIs, which is a core part of, your design. So this is where this API design assistants are coming to the picture. So for example, can you describe your API requirements and can you generate the schema or the specifications? APIs have, as you may know, specifications, right? So the REST has the REST open API specification and the GraphQL has GraphQL schema. So then the question is, given the natural language description, can you, generate these schemas and endpoints, right? So the difference here is that when you have an internal developer platform, you can made aware this platform about the best practices and, certain governance policies, security policies that the organization has to follow. So then this knowledge can be embedded into these design tools. So when the specifications are generated, they will, you can ensure that those practices and all those rules are followed. And if a developer does some sort of a mistake, then that can also be pointed out to the developer as, recommendations. Right, so let's move on. So once the design is done, then you get to the code writing part, right? So there's a lot that is happening in this code writing. So there's well-known tools, right? This is a problem that has been investigated and researched quite a lot. Like there are well-known tools like, GitHub Copilot that we use, when you write code, right? They give suggestions, they can find various issues and so on. But the difference here is that, so the tools that are provided by the internal developer platform, which will coexist with these other tools such as GitHub Copilot, they are aware of what you have in your platform, right? All the artifacts, the services, also the runtime data, and so on. So when you build these applications using these tools, they can also give various recommendations and so on. So let me show you another example. For example, internal developer platforms have this concept called marketplace. So this is where all your APIs, you can, once you write a service and expose it as API, it can be published into a marketplace, right? And then developers can go and ask that they want to build a particular use case. What are the APIs that I can use, right? So then you can go and search in the marketplace to see what APIs, that he can use to implement that particular use case. You can even go to the extent of, describe a particular scenario that you want to implement. This can be an integration, for example. And then, you can even generate the code, right? Now, this generation will require basically use the specifications, because based on the specification, you can generate the code and then you can, you know how to interact with those APIs. That is what the specification will tell you. Okay, so you've designed the software, I mean, the architecture, and then you have written the code. The testing is the next important part, right? So the first phase of testing is the unit testing. Actually, this should be more on the other side, because once you write the code, you can generate the unit test, but I have listed it here. But then there is other kinds of testing that you can do. There's API level testing, for example, right? And then you can, generate this API testing, and also you can validate the responses. Now, all of this is done mainly using the specifications of these APIs. So once you know how to interact with these APIs, then you can test it, you can generate the test data, because the schema or the specification will tell you what kind of payload that it accepts, the format, right? So then you can generate sample data. Okay, so here I have a small video. So this is something called API chat. This is a very, very small tool. So a developer has written, implemented the service, and then he has exposed it as an API. Now you want to quickly try it out. So this is doing it in the developer environment. So here what we try to do is, so usually the pattern is that developer needs to look at the specification and understand what kind of message it accepts, and then craft that message manually, and then send a request and get the response back. So in this case, you're actually interacting with that API directly in natural language. You tell what scenario you want to test it, or you can test all the resources. And then the AI will, since it knows, aware of the specification, it can go and figure out endpoints to call to basically achieve that particular task. This is not just one endpoint, it may have sequence of endpoints, and then it will send you the response. Right. Okay, we've talked about, right. So now you are transitioning from have designed it, and then you have coded it, and then you have tested it. Now you're transitioning from the design to the runtime, right? So this is where you go and deploy your application, which is running in the internal developer platforms. Now, so here now, so the earlier use cases mostly involve generative AI. Now, when it comes to the runtime aspects, it's not necessarily Gen AI. You have to use other types of AI as well, traditional AI, or I mean, they spoke about adaptive AI, so adaptively improving your system, right? So one use case here is, of course, the anomaly detection and troubleshooting. Again, you are talking about an enterprise application running in the internal developer platform. You have microservices interacting with each other and also with the external world. So you can, collect all of these data, analyze it together, and detect various anomalies, and then alert the users. So that's the first use case. Now, once they have been alerted, then they come to internal developer platforms to see what has happened. Then you can assist with troubleshooting, which is a second use case, to pinpoint where the error might be. Okay, so there's work being done in these areas as well. Right. So, and then there are various other kinds of optimizations that you can do. Now, one, for example, is the cost optimization. So those who are actually, using cloud-based platforms to deploy, their microservices, or your applications know the cost of your bill can go up in no time. So the cost is a major issue. So then, so the internal developer platforms, I mean, what we try to do is to basically minimize the cost as much as possible without impacting the performance. This is the multi-objective optimization problem. So we are working on this problem heavily. So which will save money, right? So there are various kinds of optimizations that you can do. For example, look at how the these microservices are consuming resources, and then, if the resources have been over provisioned or over allocated, you can go and, adjust those things to the right levels. And also there is use cases such as auto scaling. How can you make it smarter? Can you go beyond the standard default algorithm? All of those things can be done, right? Okay, so now I have gone through a set of use cases which is applicable for IDPs, or internal developer platforms. Now I want to briefly, take a look at how to build a co-pilot for such a platform, right? So what does this co-pilot do? This co-pilot will interact with this software engineering or internal developer platform so that the developers can go and ask various questions from different areas, because it covers a broad spectrum, right? As I pointed out earlier. Now then we have the question of, do we do a domain specific co-pilot, right? Because this platform has multiple different areas. It covers, there's a marketplace for APIs, there is observability data, then there is, engineering analytics, whole kind of, or do we go ahead and build a universal co-pilot that where the developers can go and ask questions from any area? So we have actually done both. So one important point is that once you have a universal one, you can give a more cohesive user experience. For example, by connecting the runtime data and code data together in a connected way. All right. Okay, so building this universal copilot, let's talk about it a bit more. So in order to do this, you'll have to actually tap into this platform's internal APIs. So because you have different data sources, there's an architecture diagram, I'll show you that. And this data is exposed through this API. So the AI will basically talk to these APIs to, retrieve the data. So that's the main pattern. So the API basically sits in the middle as the main interface, right? Of course, if there's no APIs, then you'll have to, introduce new APIs, because you don't try to directly connect your AI to the data source. That is actually too risky, because then if the AI hallucinates, for example, you can get into issues like data leakage. Once you have the API layer, you can completely avoid that, because AI will only talk to the API. So the authorization, which data only the person who has permissions can access. Even if there's a hallucination, it will only result in an accuracy issue, right? Okay, so this is the kind of one possible architecture. So you have the user, and then you have the chat-like thing, which is the chat UI, and then you have the Copilot agent, which will interact with the internal APIs of this platform, right? In addition to this, if you want to say, for example, bring the documentation or whatever, you can build a RAG-like system. That's the well-known pattern, right? Put your documents into a vector database and expose that as an API and connect to the same Copilot, right? Now, there are two patterns which we have used to build. This one, of course, is all we know is the RAG pattern. The other important pattern is this tool calling pattern. Given set of tools, how can I get AI to call them? So this is the AI API interaction, which I was talking about before. So an API will have multiple resources, and one of those resources will become a tool, right? So that's the other pattern which we have used to build this Copilot. Right. So then this is the last slide on this. Now you ask the question, can you have one universal API? That is fine, which is what we are going to do. But does it make sense to connect this one agent to all of these AIs? Because it spans across multiple different areas, right? So what we've realized is it doesn't. So you have to have this multi-layer approach where you have a central copilot, and then you have domain-specific agents, or you can call it copilots, which will then go and talk to these domain-specific APIs. So that's the architecture which we have adapted, which has resulted in significant improvements in the accuracy also. So this is the high level architecture. This is currently work in progress, but the customers are already using this. Right. So let me now try to conclude. Right. So as you have seen, inter-developer platform solves a significant problem in software engineering. Right. Now, one thing that is becoming popular is companies are making an effort to build internal developer platforms and making it available as a service so that the others can go and use these platforms. They don't have to build it themselves. Right. So this is becoming increasingly popular. Now, so when it comes to AI, there are two things which in the context of AI for internal developer platform. First one is AI for internal developer platforms. That is what I called it initially. That is about increasing the productivity of developers who are using these platforms, which is what we focused on today. But then there's also another one where you want to integrate and build AI applications. You want to innovate. That is you building co-pilots for yourself as a developer, right? Not the platform improving the productivity improvement. So that one we haven't discussed in today's presentation. We can take it up in a different session. So I have gone through a wide range of use cases, starting from the design to and then development, and how it differs from the normal coding like practices, because you can make development tools aware of what's in the internal developer platform, and then you can give an integrated user experience, for example, by combining the runtime data and the code data, right? Which is not something that the GitHub Copilot can provide, right? Then I looked at, for example, then I looked at how to build a Copilot for these internal developer platforms that will integrate with its internal APIs and give you that unified kind of experience. Now, this Copilot doesn't cover all the use cases I mentioned. It covers only some of them. Right, I think that would be it. And thanks a lot for inviting me. If you have any questions, you can ask.